In previous videos, we've talked about isotopes or atoms that have certain number of protons but different numbers of neutrons. For instance, carbon-12 has 6 protons and 6 neutrons, but carbon-14 has 6 protons and 8 neutrons. Today we're going to talk about mass spectrometry and how we use all of the various isotopes of an element to come up with a suitable atomic mass. The atomic mass given on the periodic table is the average of the mass numbers of all known isotopes, weighted by their abundance. This is known as mass spectrometry. For example, the mass spectrum of selenium. Here, the most abundant isotope of selenium has a mass of 80, but there are 4 other isotopes that have been discovered for selenium. The average atomic mass is the weighted average of all 5 isotopes of selenium, shown in the graph. This value is also called the molecular mass, or molar mass for short. We use AMU, or the atomic mass unit, as the unit for molar mass. To make things simple, just know that the symbol for an AMU is U. The molar mass will always give you a pretty good idea of the most common isotope for that element. For instance, the molar mass of carbon is 12.01, and about 99% of carbon in existence is carbon-12. Let's try an example. The mass spectrum of iron looks like the following. Use the data on the mass spectrum to estimate the average atomic mass of iron. Our y-axis represents the relative abundance of each of these isotopes, or a percentage for how common they are. The x-axis represents the mass number for each isotope of iron that can be found. We can see from the graph that iron 56 is the most common isotope. Iron 58 is the least common isotope found for iron. We can determine the average atomic mass for iron by taking each mass number, multiplying it by its percentage, and then adding all of our values together. When we do this, our answer comes to be somewhere around 55.9 atomic mass units.